So hello everyone, my name is Taiken, and this is my partner Andrea, and today we'll be talking about project song genre classifier. So music is essential to, it's an essential part of society and culture, and all different types of music exist all over the world. So currently, genre classification of music is done by using a combination of the lyrics, the audio data, as well as the song metadata. But we want to see if we can just classify the genre of the song using the lyrics alone. And this might be useful for like these streaming platforms such as like Spotify or Apple Music in their recommendation and sorting algorithms. For our data set, we combined like multiple data sets off Kaggle. And we also augmented that data set by adding more data points for underrepresented genres by scraping them off like Spotify, using APIs, Spotify APIs and Music Match, and we scraped those lyrics for those underrepresented genres. We also did a manual labeling of the secondary genres for some of the songs, and we split this across the 3 data sets, and in total we had 1,750 songs per genre. So just like a quick dive into the data. On the right, we have the unique words, number of unique words found in each genre, and it kind of varied throughout the genres. And on the left, we have word clouds for rock and indie. And as you can see, they're quite similar. In fact, 68% of words found in indie are also found in rock. And this actually caused like a kind of issue, which Andrea will talk about later on in our presentation. For the data processing, we tokenized padding, and we left in the punctuation. For our baseline, we removed the stop words, and we also removed new line characters. For our baseline model, we used term frequency inverse document frequency, which kind of just represents the relevance of a word inside some text. And we took that and we put that into some simple classifiers. And the best classifier, or best accuracy we got, was logistic regression. And as you can see from the accuracy per genre table, actually pop, indie, and rock had very low accuracies compared to other genres. For our main model, we used a transformer, so we tried GPT-2 and BERT. The best performance we got was from GPT-2, and we added like a classifier head, which consisted of 2 linear layers with some dropout and an activation function in between them. We also changed the model in training so that if the prediction matched the secondary or primary genre, we would accept that as a correct output, and we would also update the loss correspondingly. I'll pass it to Andrea.
So in terms of performance metric, we look to use accuracy across all the genres, and we were able to achieve 76% accuracy across all the genres. One thing to note is that during model training, a few things we did differently. First was accepting multiple genres as the correct output, as Pankaj mentioned, and then also we reduced the number of classes from 8 to 6. So we actually excluded the pop and indie genres from our training data set. And I'll get into this a bit later, but it helped with the class overlap problem. So just to show a bit more about the performance across genres, here's a confusion matrix showing the predicted versus true labels. So the model actually did really well on the EDM and hip hop genres. And it also did pretty well, over 70% accuracy on the blues and country genres as well. We do see, however, that it was a little bit more confused in distinguishing between R&B and rock genres, as well as the R&B and hip hop genres. So in terms of the qualitative results, we took a look into the difference between the model predictions, whether they were correct or incorrect. So as we see with the first example, the label was R&B, but the model actually predicted hip hop. And actually looking into kind of the words and style of this song, it kind of seems reasonable that the model predicted what it predicted, just because, again, the style seems similar to what would typically appear in a R&B song. And then with the second example, we see that the model was able to successfully predict the blues genre here, which means that it could have picked up the repetition or style characteristics that are common to the blues genre, for example, with the 12-bar blues. So one of the main problems that we ran into was the fact that songs can be assigned to multiple genres, so classes are not mutually exclusive. And we saw this with just the number of secondary genres that appeared in the data set along with primary. So actually removing the indie and pop genres from this training, by removing them, we were able to solve some of the genre overlap problem. And we did this because indie is actually a subgenre of rock and pop, and then pop itself is representative of popular music, which itself could encompass a variety of different genres based on whatever the hits are. We did find that the model was confused a bit between the R&B and hip hop, as well as blues and rock genres. These were two pairs where we found that songs could kind of appear or be labeled together as. And then in general, we found that while prediction task was successful, it did have some limitations. So we found that it would be more useful to kind of enrich the data set and consider other audio features to achieve more accurate predictions. So if we were to start the project again, some things we would do would include a more thorough data exploration, as well as spend more time trying to enrich our data set as mentioned.
Okay, thank you.